This video is brought to you by mywayteaching.com.
In this part, we are dealing with the combination of errors. When we do an experiment involving several measurements, we must know how the errors in all the measurements combine. For example, in an experiment to determine the density of any substance, we measure mass as well as its volume. So when we measure the mass as well as volume, errors will be introduced into the system in both the cases, which means while measuring mass and even while measuring volume. So this is nothing but combination of error, isn't it? Then we must know what the error will be in the density of substance. Okay, when we add the errors that we get in measuring these two quantities, mass and volume, we get the total error in the density of the substance. So now let us see errors in sum and difference. Suppose two physical quantities A as well as B. Okay, just consider two physical quantities have measured values. Okay, that is given by A plus delta A and B plus delta B respectively, where delta A and delta B are their absolute errors. Okay, we know this, isn't it? Delta A and delta B, what are these? They are absolute errors. So, after addition, we have Z is equal to A plus B. When we measure this physical quantity, we get error. So, Z plus delta Z is equal to A plus or minus delta A and B plus B plus or minus delta B. Okay. We can also write this as A plus B plus or minus delta A plus delta B, isn't it? Yes. So the maximum possible absolute error in Z is given by delta Z, whose value is delta A plus delta B. Similarly, we can get the value for difference. In case of difference, we know Z is equal to A minus B. So when we measure, an error will be introduced into the system. So Z plus or minus delta Z is equal to A plus or minus delta A minus B plus or minus delta B, isn't it? Yes, we can also write this as A minus B plus or minus B So we can also write this as A minus B plus or minus delta A and minus plus delta B. Okay, and the error plus or minus delta Z is given by plus or minus delta A minus or plus delta B. So here there are four possible values, that is given by plus delta A minus delta B plus delta A plus delta B minus delta A minus delta B minus delta A plus delta B, isn't it? These four are the errors that we get in measuring the quantity. So in comparing in these four errors, which is the maximum one? Is the maximum value of absolute error in Z is given by delta A plus delta B. Okay. So hence the rule, when two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Okay. When two quantities are added or subtracted, the absolute error in the final result is sum of the absolute errors in the individual quantities. Okay. Now let us see the errors in multiplication and division. So first we'll consider multiplication. Suppose we measure Z is equal to AB. Okay. Values of A and B are A plus delta A, B plus delta B. Then Z plus delta Z is given by, the errors will be introduced once we measure it. Okay. So if you multiply these two quantities, we get the value as AB plus or minus A delta B plus or minus B delta A plus or minus A, that is delta A delta B. Okay, this is the error which is introduced in case of multiplication. So if we consider division, again we should consider the same experiment, that is Z plus or minus delta Z is equal to A plus or minus delta A by B plus or minus delta B. Okay, so if you divide LHS by Z and RHS by AB, we'll get the value as 1 plus or minus delta z by z is equal to 1 plus or minus delta a by a plus or minus delta b by b plus or minus delta a by a into delta b by b. So in this case we can ignore delta a by a and delta b by b product. Okay, we can ignore this because the value of this product, that is delta a by a and delta b by b, is very small. So after division, the maximum fractional error in Z is given by delta Z by Z is equal to delta A by A plus delta B by B. So this is the maximum fractional error. So here the rule: when two quantities are multiplied or divided, the maximum relative or fractional error in the result is sum of the fractional errors in each quantity. Okay, when two quantities are multiplied or divided, the maximum relative or fractional error in the result is sum of the fractional errors. Okay, this is a fractional error, isn't it? The sum of the fractional errors in each quantity. So this is all about the combination of errors in case of addition, subtraction, multiplication and division. So in case of addition, if we consider, the maximum relative error will be delta z is equal to delta a plus delta b. So in case of subtraction, the error we can write it as plus or minus delta z is equal to plus or minus delta a minus plus delta b. Okay, and in case of addition, the maximum error is this one. So in general, if I want to write, then again we can write as plus or minus delta z is equal to plus or minus delta a plus or minus delta b. Okay, and in case of multiplication and division also we'll get the terms. So in case of multiplication, we get the value that is given by delta plus AB plus or minus A delta B plus or minus B delta A plus or minus delta A delta B. So this is the error in multiplication. Similarly, if we consider division, the fractional error delta Z by Z is given by, that is the fraction individually, that is given by delta A by A and delta B by B. Okay.